Hello guys, so today I'll be solving this problem. So the problem states that we have been given n strings, okay, and we have to choose some deletion indices, okay. Now how this deletion indices will impact is like I have been given the strings all of same length, okay. Now whichever indices I am choosing, they will delete those indice characters in every string, okay. Now I need to make sure that whatever characters, like after all the deletion, whatever strings are left, okay, they should be lexicographically shorted, okay. Now I need to return the minimum possible value of my length of deletion strings, okay. So if I put it in this manner, so here I have a b c d e f, okay. Let's call a, okay, so let's call a b c d e f, okay, then u v w x y z, okay. So here in this string I have this indices, okay, 1 2 3 4 5, okay, cool. Now here if I look, okay, so these two strings are already lexicographically shorted, but I can choose some indices, okay. So I can choose this, maybe this too, okay. Now I will delete uh, these pairs, okay. Let's do it in a different color, okay, this and this and this, okay. Now after that they will be left with bd, okay, and ux, okay. So here if you see, okay, bd and ux, okay, so bd is already lesser than ux, okay. So yeah, they are following lexicographical sorting manner. But if you look at, I have deleted 4 indices, okay, but the strings are already lexicographically sorted, which means here the answer should be 0. I don't need to delete any column, okay. Similarly if I look at this, okay, so I have ca bb, then I have ac, okay. So these are my column indices. Now I'll check. So columns and I have rows, okay, cool. So 0 1 2, okay. So for this first column, okay, I'll check inside my rows whether this is following in a lexicographical order, okay. So here I have C, here I have B and A, okay. So this is not following lexicographical order because C is not less than B, okay. So in the first iteration itself I found out that, okay, this entire column is not following lexicographical ordering, so I can simply delete it, okay. Now I'll check for this column, which is ABC. Here all the characters are following lexicographical order manner, so here the answer should be 1, okay, cool. So this problem is pretty similar to what we have gotten in the previous day solution, like in the previous day problem, which is delete columns to make sorted. So here we only need to consider, or we only need to give out the answer for the number of columns that needs to be deleted, which are not lexicographical manner. But here the catch is you can delete the columns, but the string should internally follow up lexicographical sorting, okay. So it not just the columns need to be sorted, okay, strings should follow uh, sorted fashion, okay, after deletions, okay. So whenever we are deleting columns, we should preserve their sorting order, okay. Now how this is different from previous day problem, okay. So let's look at a test case where I have, let's say, c k t m, okay, and I have z q k and let's say z, okay. Now here, okay, as per previous problem, okay, we only need to delete those columns which were not lexicographically sorted, okay. So if I look at here, okay, based on previous question, okay, which is this part 1, okay, so here cz are sorted, so I don't need to delete it, it's good, okay. kq, okay, k is lesser than q, this is good, I don't need to delete, okay. Now I have t and k, okay. T and k, t is greater than k, right? So I need to delete this, okay. So 1, okay. Then I have mz, okay. So in mz, m is lesser than z, okay. So this is also good. So here, as per the previous day problem, here answer should be 1, but the current problem says that I need to return the minimum number of indices, okay, such that uh, the strings after the deletion should be sorted, okay. So here, as per today's problem, I have this C and Z, okay. Now in this CZ, C is strictly lesser than Z, right? Which means whatever characters are after this, okay, like K can be Z also, okay, I don't care, because once I have found two characters at the same indice for a string where they are different, and one is following this manner, like C is lesser than Z, so whatever comes after C, okay, let's see K, maybe T, Z, Z, multiple Z, okay, all of this will be always lesser than Z itself, because C is strictly lesser than Z, okay. So whatever suffixes I'm adding in C, okay, those will not increase the rank of C, okay, it will be still lesser than Z. So that's how lexicographical sorting works, right? Lexicographical sorting, right? So yeah, here, since I have already gotten a character pair where where they are following strictly lesser than thing, okay, so whatever characters I have, I don't need to look at them, okay, I can simply skip them, and if I skip the rest of the column, that means my answer will be 0, okay, because these two are already following lexicographical ordering. I don't need to do any deletion in order to make them lexicographically sorted, right? So yeah, that's the difference between previous day problem and current day's problem. So yeah, so what we can do is, since the constraints are pretty small, okay, the number of strings that we can get is at max 100, and the maximum length of a string can be at max 100, okay, so we can solve this using a brute force solution, okay. So how this will look like is, so what we can do, so similarly how we solve it here, we basically iterate over all the columns. Now for every column we iterate over all the rows, and we check whether those rows are following uh, whether the rows are in a shortened manner or not, okay, for every character. If they are, we are good. If they are not, we are incrementing my answer, okay. But here what we can do is, in order to preserve the strings comparison itself, okay, we can start storing prefixes, okay, and try to add current characters to check whether those prefixes are lexicographically sorted or not, okay. So how this will work is, so for example here, okay, or maybe I can take another example. But yeah, let's take this example only. So I have C A, B B, I have A C, okay. So columns, rows, okay, 0 1 2 0 1, okay. So what I can do is, I can have a data structure that stores for every string that I have a prefix version of them, okay. So by prefix I mean it will store those characters which I have not deleted in that string, okay. So let's call it prefix. Why prefix? Because since I'm keep on storing the characters that are starting from the first, that's why I'm using prefix, okay. Cool. So initially for all of them, these will be empty, okay. Now we'll start iteration, okay. So in my first iteration, okay, in my column I'll check, okay, for every row, okay. Now I'll check C and B, okay. Now C is not less than B, but it is appearing before B, which means this row entirely should not be, or this entire column should not be stored at all, okay. Or basically all the characters that are appearing in this column, they should be rejected, okay. So I'll reject this column, okay, and I will not update my prefix, okay. Cool. Now now have ABC, okay. Now in this entire column, all of the characters are following lexicographically, all of them are sorted, okay, which means I can add up these characters in my prefix, okay. I will add A, I will add B, and I will add C, okay. Now let's say I have another character, okay, let's say this guy has T, this guy has U, this guy has let's say A. Okay, now in this third iteration, okay, I'll keep on checking. Okay, T is less than U, all good. Okay, and now U is not less than A. So how I will be checking is, so I'll take this prefix, okay, and I will add up my current character, okay, which is plus T. Okay, similarly for this comparison I'll be using uh, so basically I'm saying for every comparison that I'm doing, I'll be using this entire prefix that I'm creating, okay, and I'll be adding up the current character. So for example, when I compared this two, okay, so I'll be doing A plus T, okay, whether it is less than or equal to B plus U. Okay, I'll be using prefix instead of the strings itself, or instead of characters. Okay, so using prefix will help me to preserve the lexicographically ordered in fashion. Okay, because I'm building my prefix or I'm updating my prefix only when all of the characters are in a shortened manner, right? So internally it is storing all the prefixes in lexicographical manner. Okay, cool. So that's the idea. So once I develop this prefix, okay, I can do this kind of comparison. So using this comparison, I will know whether I have a character in the past that has already been lesser than my current character. If it is, then I can skip my current iteration. So yeah, that's how I'll be using prefix. So if I write a brute force code, so it will be something like um, I will iterate over all the columns. Okay, so for column starting from C to calls. Okay, so here I will store my rows and columns. Okay, and I will update my answer to 0, or like initialize my answer to 0. Then I will need this prefix data structure that will store whatever characters I have taken for every string till my like until my column iterations. Okay, so I'll be using prefix. Okay, and I will initialize it with the number of strings I have, that is number of rows. Okay, and it should be of string data type. Okay, now how I'll be using it is, so I have column and this. Okay, now in order to update my prefix, I'll be using a flag. Okay, let's call it all okay. All okay, I will set it to true. Okay, so at first I'm assuming all of my rows are having shorted fashion of characters. Okay, so I will initialize it to true. Then I will iterate over all the rows. Okay, I will start with 1, 2 rows I have, and row plus plus. Okay, why row 1? Okay, because I can simply check whether my previous, I can take my previous and my current character. Okay, so I can start with 1. Okay, now I'll check, I will say if my prefix that I have, okay, for the previous string, which is r minus 1, okay, and if I am adding the current character, okay, which is the strings that have been given. Okay, so my previous string's current character, okay, I'll compare it with my current string's prefix, okay, plus the current character I have for in this iteration, which is row and C. Okay, if this is less than equal to, okay, then I'm good. Okay, I haven't found any strings where they are different, and this is of the reverse logic. Okay, so I can simply continue. Okay, but if this logic is not satisfying, that means I have found a position where for this current column, okay, these two string pairs are not following shorted fashion, then I can update my answer to plus equal to 1. Okay, and I will update all okay to false. Okay, and I will break out of this row iterations. Okay, cool. Now I'll check if in my iteration all of the rows were satisfying shorted fashion of characters, then I'll update my prefix. Basically I'll add up those characters. So I'll say for row 0 to rows r plus plus, okay, and I can add one more check, okay, and add with all okay r plus plus. I'll update my prefix with prefix of my rth string plus equal to string or the rth string plus the current character that I have in this loop. Okay, now this logic will work because my prefix is holding whether the characters are already in a shorted fashion or not. Okay, and yeah, with that I will be solving the problem. Okay, like finally returning the answer. Okay, so this will work. Okay, because if I look at the time complexity here, okay, so the time complexity is, so I have the number of columns which is nothing than the maximum length of the string. Now all of the strings are of the same length, so let's designate length as length of a string here. Okay, so this will be the number of columns I have, which is len or big O of len times. Now for every column I'm doing a row wise comparison, right? So which is, and the number of rows I have is the number of strings. Okay, so number of strings. Okay, now whenever I'm comparing two strings, okay, I'm doing a string level comparison, right? Like prefix is a string, okay, prefix of r minus is a string. When I'm comparing this is a linear order comparison because character by character I'll be comparing them. Okay, then that means the maximum character length I can get is this thing only, so this will be times len. Okay, and after this I'm again doing a number of string iteration. But if you look at here, okay, or if I erase this, so the final time complexity, this will be plus number of strings. Okay, now this part will not impact much. Okay, this will be this because for every column I am doing this number of string iteration and comparing, and then for that index itself I am updating my prefix, which is again the number of strings I have. Okay, so yeah, this is the time complexity. Okay, and at asymptotic time or at my worst case, this part will rule. Okay, so I can say my overall time complexity will be big O of len times, or I can say len square times the number of strings, because len times number of strings will be negligible as compared to this. Okay, so my overall time complexity will be ruled by this. And similarly for space complexity, okay, I'll be using this auxiliary space for to store my prefix, and there I'll be storing strings. Now those strings will be the number of strings I have, and their length will be at max len. Okay, that means a big O of number of strings I have, and for each of them I'll be storing len amount of characters. So this will be my space and time complexity. So this solution will work because if I check out here, okay, my time complexity is big O of len square times number of strings, right? So my len at max can go to 100. Okay, 100 square times the number of strings I can have, which is 100, right, as per these constraints. So if I look at here, this will be what, 10 to the power 4 times 10 to the power 2, 10 to the power 2, okay, which will be approximately like, or like close to 10 to the power 6. Okay, like it will be 10 to the power 6 plus some change, but yeah, it will be 10 to the power 6 only. Okay, now a million number of operation is not an issue. Okay, and we can do it. Okay, but the issue arises when we are in like 10 to the power 8 or 10 to the power 9 range. Okay, but here with this brute force solution, okay, as per the constraint, we are good. Okay, we are only doing 10 to the power 6 operations, right? So this will pass. Okay, similarly for space complexity also, so this is like number of strings and number of length, so this can at max go to like 10 to the power 4. Okay, so with this we'll be good. Okay, and we will get acceptance, but it will not be fast. So how can we make something fast? Okay, or make this algorithm fast? Now if I look at this algorithm, okay, so the main issue is this guy. Okay, because here I'm comparing strings with strings. Now when I'm comparing strings, they will be doing character by character comparison. Okay, can I do something better? Okay, now let's recall. So what happened in this test case? Okay, so once I have a character, okay, which is strictly lesser than my current character, okay, then I don't need to care about whatever characters are in like are after C in this case, right? So can we use this information to fasten up this? Yes, we can use. So one thing is, once we have found uh, positions, or let's say once we have found uh, ith characters for one pair of string. Okay, so by pair I'm saying my r minus 1 string and my r. Okay, where uh, the strings of r minus 1 of I is strictly less than strings of my rth string, ith character. If this is strictly less, okay, so whatever characters, okay, I have from r to, let's say, I plus 1 to n, okay, I don't need to check them, because I already found you can say a point where they are differing, and this guy has been like ruled out to be higher, or like more in the lexicographical order. Okay, so I can avoid this. Okay, so I can, instead of storing prefix, I can have a data structure that can tell me whether I have like this guy or my rs string is already sorted with its previous guy. So yeah, I can use this information. Okay, now the next information I have is here. Okay, so here I am updating my prefix. Okay, so what I will be doing it here is, so that data structure that is telling, okay, or the cache data structure that is telling whether my current rs string is already sorted with respect to its previous string. Okay, I need to update that cache, right? So how I will be updating? Okay, so simply I will iterate over all the rows, okay, or the string, but starting with 1, because the update logic should be, if in my iteration, okay, r plus plus, okay, if my previous guy, which is like, let's say, strings of r minus 1 with respect to the current character, if they are strictly less, okay, with respect to the strings of r of c, okay, then I can mark my cache, okay, or let's give it a good name, like is sorted with respect to above, something like that. Okay, I can mark this cache for my current string as true. Okay, now how this will help me is, so whenever we are looking at strings, let's say s1, s2, s3, s4, okay, and let's say there are sn strings. Okay, if I can prove, okay, sn, if I can prove the strings are pairwise sorted, okay, in this manner, then that means the overall strings, okay, they will be in sorted fashion, right? Just think about it. every pair is sorted among themselves. Okay, like pairs like this s1 s2 s2 s3 s3 f s4, if they are sorted among themselves, now the overall like list of string will be sorted. Okay, follow that, like we are storing in, like storing s1 first, s2 second, and s3, right? So I can use my cache data structure to check whether they are pairwise sorted. Now, if they are pairwise sorted, finally I'll be having the information whether the overall strings that I am iterating over, okay, those are following lexicographical ordering manner or not. So yeah, that's the idea. So I will I will start with the brute force, okay, but I will not be coding the brute force, okay. I will show you how you can apply this cache kind of a logic, okay, to fasten up this time complexity, okay. Now the codes are pretty similar to what you guys must have been implemented in this problem, so I'll simply copy this code, okay. I'll simply show you how you can use this code and this cache logic to solve this problem, okay. So yeah, so rows and columns has been collected, okay, the number of strings and the length of the string, okay. Then I have my answer array, like answer variable. So I'll need one data structure, okay, to tell whether the strings are pairwise sorted or not, like, okay. So I'll say is sorted with above, okay. So I'll initialize this to all false and 2 rows the number of strings I have, okay. Now after that I'll be again using this all okay flag, okay, because this will help me to check like to say whether I need to update my is sorted above data structure or not. So I'll say all okay, so all okay to true, okay. Now I'm assuming my rows will be sorted, okay. Now if in my current row, if is sorted with above for my current row is already true, which means I have already gotten a like I have already gotten a character where this my current row is like strictly increasing with respect to my previous string, okay, then I can simply do a continue, okay. I don't need to do these operations, okay. but but if it is still false, okay, I haven't updated this, okay, I'll be checking, okay, uh, for current character and the previous character, if they are like less than equal to, or they are already in a, like they are following sorted fashion, I'll be continuing. If they are not, then I'll be updating my answer, and I will also update my flag, which is all okay, set to false, okay. now now I will update my is sorted with above, okay. I'll say if all okay, okay, all okay, is this right? Yeah, if the entire row for this current character, okay, all of them are sorted, okay, then I just need to check whether they are sorted, but are they following strictly lesser than condition or not. If they are, I'll update my cache, so which is this. So I'll write for r in range 1 to the number of strings I have, okay. Now for every string I will check if strings of r minus 1 of c, okay, is strictly less than my strings of r of c, okay. Then I'll update my is sorted with above of r to true, okay. Now this will help me to quickly uh, get my iterations done, okay, cool. So sorted true, and yeah, this will help me to get the cache out answers. Now I'll be checking, and yeah, I think I'm good. I can run it for all test cases, and voila, I got an error. Cool. Now here the issue is, yep, I cannot access string character by this, so I'll need to use as bytes, what I have used it here, what I have used here. So dot here along with the dot here, function call. This is also function call of c, and I'm checking whether they are sorted, and yeah, let's check. And it didn't work still because strings of this, if condition is this, it's saying, okay, there is no range first. Oopsie. Oh yeah, there is no range keyword. But more than that, if strings of this expected identifier found key. Let's run it once again. Ah, no, it passes. Yeah, that's because of the range word. And voila, it got accepted. Now, if I look at the time complexity here, okay, now I'm not doing a length like string level comparison, right? Okay, my cache is already telling me whether I have already found a character where the strings are already in a shorter fashion or not. Okay, now using my cache, I have ruled out this extra len time complexity that I was doing. So my modified time complexity is now, so still like the len is there, okay, times the number of strings, okay. Now here all of them are constant time operation, and after that I'm also doing number of strings iteration to update my is shorted above data structure. So this is len times number of strings I have, okay, times 2, okay. So in a general sense we can say like big O of len times the number of strings I have, okay. And space complexity wise, okay, that also is reduced because I'm not storing this extra len for every string, okay. So that has reduced to the number of strings I have, okay. So big O of number of strings, okay. So this is my overall time and space complexity. Let's draw the box correctly, and yeah, voila, cool. So this is the Rust solution. It got passed. We are in 0ms, but yeah, never trust this. I'll just quickly show you how to do in C++. So the codes are pretty identical, okay. So here also I'm creating this is shorted above data structure. Now I'm using it as a cache, okay. If for my rth string I have already found an index where the previous index and my current index are differing in a less than manner, not less than equal to, like strictly lesser manner, then yeah, I'm simply continuing for that. Otherwise, if it is still false, I'm checking row by row, okay, and I'm updating my answer, and I'm using this updating my flag so that I can use this flag to update my data structure. So the same code that I have written in Rust, okay, this is the C++ version of it, okay. I'll just do one more this and a bit of this, yeah. So the same code, okay, just the syntax different, okay. So if I submit this, and yeah, got passed. Now finally for the Golang code, now this thing is pretty similar to what we did, like what I showed you for C++, okay. Here also, so only syntax and initialization difference, but the actual core logic, okay, that is bit by bit like same, okay. So instead of all okay, I have just created this all good flag, okay. But here again I'm using this cache like I described, like how I'm using it. Then yeah, string level string character comparison, and if something is bad, set this to false so that this will not update my data structure, okay. So yeah, that's the Golang code. Now if I submit this, and voila, it got accepted. So yeah, I hope you guys learned something new, and if you like the explanation of this solution, please do subscribe to the channel and put a like in this video. But if you are like stuck at some stage, please do comment, okay. By that only I will know like okay where I'm lacking, okay, what section I could have explained better, okay, and what kind of explanation you guys are lacking. I can get those analytics data, okay, then I can do a better job. So yeah, please do feedback me, okay, that will help me a lot, okay, that will also help my channel to grow, okay. So yeah, that's the idea. So yeah, just stay tuned to watch more videos. Thank you, bye bye.